All right, so in this video, we are going to talk about the sine graph and some transformations that happen with this graph and where they come from in the function. So the first thing we're going to look at is quadrant 1 of our unit circle. Now I'm going to do a couple things. I'm going to use lots of different colors. So I'm going to start by just doing degrees. So thinking back to what we did previously, if I'm thinking of just the start, this would be 0 degrees. And the other major one we looked at straight up was 90 degrees. And then this is halfway in between, so this is 45 degrees. And then my other two special angles that I talk about all the time with sine and cosine is 30 degrees and 60 degrees. Now I'm going to turn these into radian measurements as well. Whether you're going into Math 4 or Math 171, which is pre-calc, you're going to more than likely be dealing with radians instead of degrees. So thinking back to our lesson earlier in this unit, if I have degrees, I'm going to take the degree measurement and I'm going to multiply it by the fraction pi over 180. And then that fraction will give me my radian measurement. So this radian measurement is just going to be 0. 90 degrees, 90 over 180 is 1/2. So this radian measurement is pi over 2. Halfway in between that, 45 would be pi over 4. And then you can do the conversion with 30 and 60. This would be pi over 3 and pi over 6. So those are all my radian measurements. And I'm going to do sine of all of these angles. So now I'm going to do sine of theta. Now, if you're doing radians, you need to make sure that your calculator is in radian measurement. If you're using the degrees, then your calculator would be in degree mode. Seems pretty self-explanatory, but just so you are aware, make sure if you're in degree mode, you're doing degrees. So I've already done these. So in this blue color, I'm going to do the sine of each of these angles. So the sine of 0 is 0. The sine of 30 is 0.5 or 1/2. 45 gives me 0.71, and I'm going to do 2 decimal places. I'm just rounding to make our lives easier. And then this would be 1. So these values are the sine of that particular angle. And if you think back to what we did last week, here's theta, here's my right angle. This is actually our y coordinate. This is our x coordinate. And since I'm on my unit circle, our radius is 1. So our angle, the sine of theta, is y over 1, or just y. So this is just something to keep in mind for later on this week. The sine of our angle is the same as our y value. So the next thing we're going to do is we're actually going to take this, and we're not going to do all of the angles. We're going to do our main angles. We're going to do our 90s and our 45s. So one thing that may be helpful is to have some colors available. So I'm going to do my main angles here, pretending that I can draw a straight line. Let's see. We'll do blue this way. All right, so this is 0 degrees as well as 360 degrees. And then that relates to 180 degrees when I reflect it. So now in purple, I'm going to do the sine of whatever degree I'm dealing with. So the sine of 0 and 360 was 0. And again, I'm also going to do my radian measurements. So radian-wise, this is 0 and 2 pi. And I'm just going to put little boxes around my sine values so that I remember them, because they're going to be important when we move on to our next activity here. So 180 degrees in terms of radians is pi. It's halfway around my circle. And in terms of sine, this is the y value of this coordinate here. Remember, we have a radius of 1. So I've gone over to this point here. I've gone 1 unit over, but I haven't gone up any. So this sine value is also 0, reflecting over. Now if I go up to the top, this is 90 degrees. Radian-wise, that was pi over 2. And my sine value here is positive 1. We did that before. Now you'll notice that this pink line runs vertically. It's connecting 90 and this opposite angle down here that's related to 90, which is halfway between 180 and 360. So this is 270 degrees. In terms of pi over 2, each tick mark along the vertical or horizontal coordinate plane is another 90-degree angle. So I'm going to look at this in terms of pi over 2. From here, I've gone 1 pi over 2. To get from 90 to 180, I've gone 2 pi over 2, which simplifies to pi. Now I'm going to go one more 90-degree turn, which means I've done 3 pi over 2s. So this is going to be 3 pi over 2 in radians. And because this is a reflection and now I'm going down, remember the bottom half of our coordinate grid for our unit circle, all of our sine values are negative. So this sine value here is going to be negative 1. All right. The next thing we're going to look at is our 45s. So that's these here in the middle. And yes, 30 and 60 are both on here, but we're actually not going to worry about them right now with what we need to do with our graphing. Not to spill the beans, but that's what we're doing next. What we're doing with our graphing, we're okay if we just use our 90s and our 45s. And this was pi over 4 for my radian measurement. Where did my purple go? Okay, so the sine here was 0.71. Now, if I reflect this quadrant over here, in terms of the sine value, it's going to be the same. So I'm going to write this as 0.71. I'm still in the positive y values, and remember our y value is our sine. So I'm still dealing with positive values for sine. But now I need to figure out what degree measurement we're at and what my radian measurement is. Now, 45 is halfway between 0 and 90. So this is 145 degree angle. This is two 45-degree angles, which gives me 90. This is three 45-degree angles. So 90 and 45 more gives me 135 degrees. And if you heard me saying I went three 45-degree measurements, so it's 3 of my pi over 4s. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4. And I'm going to keep doing that in my head. So this would be 4 pi over 4s. Well, 4 pi over 4 simplifies to pi, so that still tracks. This down here would be 5 pi over 4. This would be 6 pi over 4, which simplifies to 3 over 2. This would be 7 pi over 4, and this would be 8 pi over 4, which does also simplify to 2 pi. Now, degree-wise, I'm going to take 180 and add 45 degrees to it, so that gives me 225 degrees, which is the same as 5 pi over 4. And then 270 plus 45 more tells me that this is 315 degrees. And again, that's 7 pi over 4. All right, now I need to think about sine. If you notice here between 90 and 270, or pi over 2 and 3 pi over 2, I had positive 1 and negative 1. So up above, sine is positive, and down below, sine is negative. So this will be negative 0.71, and this will also be negative 0.71. And those numbers that I boxed, my sine values, is actually what I'm going to use to graph. So I'm going to, sorry, not trying to make y'all nauseous. So I have a lot of space here. Along the x-axis here, this is going to be our degree or our radian measure. And I'm going to use radians just because that's normally what we would see. And along the y-axis here is our going to, excuse me, let me use proper English, is going to be our sine value. So I need to be able to graph values like 0, 0.71, and 1. So me personally, I'm going to go up 4 tick marks and down 4 tick marks. So this will be positive 1 and this will be negative 1. And then this is going to be 0 here in the middle. And we need to see enough tick marks along the x-axis to hit pi over 4, pi over 2, 3 pi over 4, pi, 5, I need to see all of those. So that ends up being 8 tick marks altogether. Now, again, because I have such a long graph, I'm going to just do every other. 3, 4, 5, 6, 7, 8. So this is going to be 2 pi. And then I'm going to start filling these in. So this would be pi over 4, pi over 2, 3 pi over 4. And I'm just pulling these numbers right off of my unit circle, which we just filled in. So it's a 45-degree turn every time I go to the next point. And what I'm going to do is I'm going to take these numbers here and I'm going to graph them. So at 0, I had a sine value of 0. At pi over 4, I was at about 0.71. Remember, I counted by quarters. So this is 0.25, 0.5, 0.75, and 1. So I'm about at 0.75. And I'm going to fill in. So these points here, oops, didn't mean to write on my paper. These points here are all of the sine values we found on the top half of our circle. Now I'm going to go to the bottom half. These are where the sine values became negative. So here I am down below. And you'll notice when you start to connect these that we get this beautiful roller coaster looking S-type curve. So this represents the sine value from 0 to 2 pi, which is one full circle. Now the coolest thing about the sine function, or one of the coolest things about the sine function, if I continued with these tick marks that I had done before, I'm going to continue going around the same circle. Now, granted, these would be those coterminal angles, or the angles that end at the same spot. But the next time I went to my next 45-degree angle mark, it's going to be 0.71 again. So these values are going to repeat. So I end up getting this curve over and over and over again that's repeated. Oh, I don't have enough room to finish, but you get the idea. And these are called periodic functions. And a periodic function is a function that has this one pattern that continues to repeat over and over and over again. And if I looked in the negative direction, I would still see that that curve continues. And there's a couple of things that we can talk about when it comes to our periodic function. And those three things are the period, the amplitude, and the midline. So if you want to pause and jot these down really quick. So coming back to my graph here, one thing we need to be able to talk about is our range. That's our biggest and our smallest y value, and that goes from -1 to +1. And remember, those brackets are inclusive. The period is how long it takes for one of my sine curves to occur, which is this is one sine curve, pretending that that looks beautifully highlighted. So normally, a normal periodic function of sine is a 2 pi rotation of my circle, which is 360 degrees, which is that curve there. Our midline, the thing that runs right through the center, is here. So that would be y equals 0. And our amplitude is how high above or below. Did I spell it right? Nope, I surely did not. But we'll just pretend it's fine. I can't spell and talk at the same time. Our amplitude is how high above or how far below we end up going. So if you look at your maximum here or your minimum down here, they should be the same distance away from that center line, and both of those are 1. So our amplitude is 1. All right. So we are going to really quickly take this graph and we're going to look at what happens on our, excuse me, get myself all situated here. We're going to look at what happens on this Desmos activity that I made, but we're just going to do this together really quick. So I'm going to come over here. So here's my function. I have A, B, and D set up as sliders. So this number out in front, if I increase that number, I'm taking the sine value, whatever it may be, and I'm multiplying it. If you think about what happened in all the other functions, if I had a coefficient, that was a vertical stretch, a vertical compression, or potentially a reflection. So let's see what happens. Let's make our A value 3. So if I make the A value bigger than 1, it's going to stretch it out and it's going to be a vertical stretch. If I make it a half, it's going to be a vertical compression. So it smushes it and makes it flatter. But what would happen if I made it a -1? Totally flips it upside down. So it used to be up here at +1 is now down here at -1. So let me go back to my other screen. So A, whoops, throwing stuff. A is our amplitude. It is a vertical stretch. Or compression. And if it's negative, we reflect over the x-axis. Oh, Lord. Can't spell again. Okay, so that's A. Next thing we're going to look at is D. If I add something to the end of my function, it's either going to move it up or move it down, which is changing our midline. So D changes our midline. If it's positive, it shifts up. If it's negative, it shifts down, which, as you may have guessed, leaves B, which is going to shift the period of the function, and let's see how that happens. So let's say I'm going to make my B value 2. Right now, you can see here I'm ending at 2 pi. If I change B to 2, yes, I'm still ending at 2 pi, but now instead of one sine curve happening from 0 to 2 pi, I have 1, 2 complete cycles of sine happening between 0 and 2 pi. If I change this to 4, I would have 1, 2, 3, 4 complete cycles happening between 0 and 2 pi. What if I change it to a half? Then I only have the top half of my function. And if I zoom out, oops, too much. Come on. Sorry, Desmos and I are having a little moment. All right, so if I zoom out, now because I've made B 1/2, half of my function shows up from 0 to 2 pi, and it takes 4 pi to make my entire function happen now. So the period, if you want to find out the actual period, we take 2 pi, which is 1 full complete cycle for sine, and I'm going to divide it by B. And that tells me from beginning up, down, and back to 0, that tells me what that value should be, where it gets completed. So let's practice with this. So 2 sine of 4x. And I need to know the amplitude, the midline, and the period. All right, amplitude is the number in front, so our amplitude is 2. Our midline is y equals 3. Remember, it's shifting it up from 0 plus 3, so that would be y equals 3. And our period is going to be 2 pi divided by 4. 2 over 4 is 1/2, so that means it's pi over 2. That means when we go to make our rough sketch, the next time I hit so from here, up, down, and back again, this is going to be at pi over 2. Now, this is the only one we're going to make a rough sketch for, just to make sure that we can figure it out from using our graph. All right. So I need to have a midline of 3, and I need to be able to go 2 up or 2 down, which means 1, 2, 3, 4, 5, 6. Okay, I just have enough to count by ones. So here's my midline. Up 2 more from that is 5. Down 2 from that is 1. And if you're the kind of person that likes to document your thinking on here, that's fine. I am too. That is our midline. 5 is going to be our maximum. 3 is going to be our minimum. So all right. Now I'm going to leave 2 pi and my main ones here. 3 pi over 2. All right. Now, sine starts and ends at our midline. And remember, I have to end now by pi over 2. So I have to make this whole S-curve happen between 0 and pi over 2. Where'd my graph go? All right. So I start and end on the midline. Halfway in between, I'm at the midline again. So halfway in between here, I have 1, 2, 3, 4 tick marks. That means right here would be halfway in between. And then in between that, I hit my maximum or my minimum. So this graph is going to be super skinny. And I could continue to repeat that. So you'll notice every tick mark along my graph, I'm at another key point. So I would go maximum, midline, minimum, midline, and that would be another curve. And again, you guys have Desmos the whole time. So I'm going to turn this off, and I'm going to put in y equals 2 sine of 4x plus 3, which looks just like the one we just created. I end at pi over 2. Halfway I was at the midline again. Halfway I was at the top. So again, I'm just doing that so you get a general idea of where the graph is coming from. We do not have to do that without a calculator. Hallelujah. All right, let's do amplitude and midline and period. So amplitude, my number out in front, that tells me I'm going 4 up or 4 down. Midline wise, there's nothing here. So that tells me I'm at 0. And for our period, I'm doing 2 pi divided by 2, which tells me I have a period of pi. So now, if you're thinking rough sketch, this would be pi. So this would be half of that, which is pi over 2. All right, one more doing amplitude and midline and period, and then we'll do the opposite and go from a graph to an equation. All right, amplitude, nothing out in front. Now this is multiplication, so it doesn't mean it's 0. It means my amplitude is 1. My midline here is going to be y equals 1 because I have a plus 1 here. And now this tells me I'm doing half of what I do normally in 2 pi. So I have 2 pi, but I'm only going to get through half of my function in 2 pi. This is the same thing as saying 2 pi multiplied by the reciprocal of my fraction, 2 over 1, which means our period here is 4 pi. That means beginning to end, it's going to be stretched out. And this is going to be 4 pi. My halfway point will be 2 pi. All right. Let's do the opposite and grab some graphs and work backwards. Now, before I even try to make an equation, I find a couple things. I find the maximum. I find the minimum. So this is 2 and negative 2. And I find a key point, whether it be pi or 2 pi. Normally, I use 2 pi. And I'm going to talk about why I use 2 pi in just a second. So, from my maximum and minimum, between 2 and negative 2, the thing that cuts that right in half is 0. So this is my midline. And then this distance is my amplitude. So right off the bat, I know I'm going to have a coefficient of 2, sine of whatever's going to happen, and then plus my midline, but it's 0, so I don't have to worry about that. All right, now if you can find your end point for one curve at 2 pi, I can determine how many are happening in 2 pi. So, traveling backwards, here's an end point, and here's an end point. So here's one sine curve, here's 2 sine curves, here's 3 sine curves. So this tells me that my period is enough to get 3 sine curves within my 2 pi. That's what this number here out in front is telling you. How many sine curves are you getting smushed or stretched in that 2 pi? So here for this one, again, I'm going to find my maximum, I'm going to find my minimum, and I'm going to find 2 pi if I can. right, so here's 2 pi, but that's not the end of a sine curve. That is the end of my sine curve at 4 pi. But let's work up to the b value. So this is 0, and this is -2. Halfway in between 0 and -2 is going to be my midline, which means this is at -1. And then the amplitude here, the distance, is 1. So my a value is just going to be 1 in this case. So I don't need to put anything in front of sine, but I do need to make sure I put my midline of -1. Now let's talk about what's happening inside here with x. My full sine curve is this. How much of my sine curve happens between 0 and 2 pi? Well, it takes 4 pi to get to the end, so that would be half. Now, there is another way you can find b. If you know your ending value for your period, that's 4 pi, and I got that by doing 2 pi divided by b. Remember, if there's a variable in the denominator, I can switch what it's equal to, and so I'll have b is 2 pi divided by 4 pi. The pi's will cancel out to 1, leaving me with 1/2. That is another way. If you distinctly know the ending value for your period, you can work backwards to get b. All right, last but not least, let's see. Here is our maximum. Here is our minimum. And I see 1, 2, 3, 4 in my 2 pi. So because I see 4 sine curves, I know that b is going to be 4. I just have to figure out the rest. All right, so here's my midline. This is at 2. So I know I'm going to have +2 at the end. Amplitude in this case, however, is not 1 because I have 1, 2, 3, 4 tick marks getting me up to 2, which tells me every other line is 1, or these in between are a half. So that would be my equation for my last function.